Okay, go for it. Yeah.
Okay, so, well, basically the articulator is a, what would you call it? It's like an animation of the lower jaw. We've had our articulator out for a while, but this is a video of the update. So I've done a lot of coding and so on in the background, and Wolfgang's changed the videos to the Facebow and the articulator.
Yeah, it's only the Facebow part. It's the actual majority of the articulator remains the same. So from constraints on, it's all exactly the same, except Michael's done a bit of coding work there, a few fail-safe, which is great. But yeah, it's mainly the Facebow. So yeah.
Yeah. So for those of you that doesn't know how this works, this is just a quick demonstration. We've taken the human skull as our example, and not so much the old mechanical devices that open the top of the jaw. We've decided rather to open the mandible instead. And it seems reasonable this way, because if we do import a CT scan, we don't want the skull like to bop up and down like that. So, all right, so just to demonstrate how this works and where the condyles end up, we're going to just parent the lower teeth to the mandible. So whatever I do here will then, should then move the skull as well. Okay. So, all right. So let's bring in the mounting table. So the mounting table is designed so that we can put the teeth more or less, to the midline, and, from the front view, and then from the bottom view, and from the side view. So this is basically an occlusal table. We use those on an articulator in a lab, for example, where we just we chuck the model on the table, and then we put plaster on the top. So that's basically the idea, but just in the digital form. So we're going to view it from the front, which we've done, and then we're going to view it from the bottom. And I have prearranged this skull earlier so that we can get this thing to the so-called stopper, which is this little thing over there. And then we're going to view it on the right-hand side. Now, like I've said, it has been pre-aligned before, a little bit of movement here and there to get it exactly where I want it to be, just to demonstrate how this thing works. So with the new update, we have a few different buttons. We can hide the mounting table, and that's then hidden for the duration of using the articulator. So we don't actually have to delete any components, which I find is way better. So we're going to view the lower, and then what we're going to do is we're going to import the condyles. So I'm going to click import condyles, and in transparent view, we'll be able to see these quite clearly. Now, these are set at 110 millimeters apart from each other, which is the so-called average intercondylar distance. I know the COIS works with 100 millimeters and not 110 millimeters. So I've got a few questions about that myself, which I'm trying to get the answer for this. But in the previous version, we would be working in edit mode, and this is way better now. You can't move these condyles; they're stuck. The only way we're going to move these is by using these arrows. So every time we click on an arrow, that would then move inwards by 2 millimeters, so 1 millimeters on each side, and then we can bring those in, or we can bring those out depending how far these condyles are
So
apart
Michael,
from each other.
can you use the grid as a reference as well? Because isn't each little square is 1 millimeter, isn't it?
Yeah, exactly. So you could basically count how far these are apart, or in the items menu, you'll be able to see, okay, these are now 116 millimeters apart. So you've got a lot of control over this, the spacing of these objects. So So let's set this back to 110 millimeters, so I can actually view this over here. I know that this is like halfway. I can double check if I want to. Okay, that's 112. We'll just click one more time, and that's 110 millimeters apart then. But of course, this mandible may be a little bit more than 110 millimeters, which I think it is, but we can verify that in a few minutes. So here I'm going to go side view, and again we've got arrows. So using G to grab it doesn't work anymore, and this is a fail-safe mechanism. We don't want people to drag these all over the scene because the condyles relate to the articulator table. So if you've got models on an articulator, for example, you can't move these hinges back and forward and up and down. So we're trying to get some type of a relation going. So here we're going to move these inwards a little bit, and we're going to move these upwards a little bit like this. And then if I'm sort of happy with where they are, and here we can see we can bring those out a little bit. So, okay, we'll bring them out a little bit, something like that. So on both sides, I'm quite happy with where they are located at the moment. All right, so once we've got that done, and we will then do that with a photograph. It's exactly the same thing, just we're using a photograph for the Facebow. We're going to then um, accept this, accept the location of these condyles. And this will bring in, okay, you can see here, over there, and over there. Yeah, here we go. These are the angles that we're going to set the articulator, and how the lower jaw is going to move along down that path, the eminence. So here we can set this accordingly if we want to. Um, you know, the default is 33 degrees, and I can see why this is 33 degrees, because it looks sort of um, quite relevant, but you can set these accordingly, and there is a procedure how to measure the angle, but I'm not going to go, I don't know too much about it, but it is quite a procedure to do that. On the actual articulator, on the condyle itself now, we will see that I have included a few angles, and so if we copy this to the right condyle, we can see this has been set to 33 degrees. So if we adjust that, we can change that accordingly.
Okay, so Michael, the screen is a little bit unclear. Is that the measurements of the angle that is temporarily imprinted on the head of
Yeah,
the
yeah.
condyle? Okay.
Okay. Wolfgang, can you just pause my screen because I need the charger for my phone because it's going to die out. If you can just give me a second. Is that okay?
Okay, yeah, that's
Just
fine. Yeah,
okay.
that's
Okay.
fine.
Sorry about the internet interruption. You there?
Yeah, all good.
Hello? Yeah.
Yeah.
All right. That's a bit better now. I can rest and work this thing through. So here we've set one, and we're going to move to the other one. Then set the left inclination, and even this is set. The default is 15 degrees, and this is quite amazing because you can actually, when you look at the structure of the mandible, how exact it is, 15 degrees. We can change this, and I do wonder how it is with children with smaller jaws. I'm not familiar, but I'd love to have a few more answers about this. But so let's set this back at default value. You can just click on the left inclination and then copy that to the condyle. So if you had set this at a different angle, for example, just say you set it up like this or like that, that this white object, the TMJ, would actually move down that slope. And this is how I've designed it, which is which is quite amazing. Whereas then the other side will move down the other angle. So it's
So
pretty good.
it's unilateral movement, is it, Michael?
Yes, exactly.
Mm.
So it'll follow that angle or follow the angle on the other side.
Oh yeah,
Okay.
that's very interesting.
Yeah.
So
Also with
if you want to fix that in place, do you press left inclination or no? That's
yes,
done
so
now. Mm.
so just say you muck it up and you put something there and you forgot what the default values are. You just click left
Okay,
inclination.
good.
That
So it's quite
resets it.
fail safe, that mechanism.
Yeah. And we've got some numbers here in millimeters, so you can actually determine how far this condyle actually moves down if you set the jaw into protrusive movement or something like that.
Yeah.
All right, so I think it's time. Let us animate this this person, this skull person. It's funny. So okay, so
Ex-person.
so in the constraints, we're going to click on Open Centric. That brings in a specific little object over here, and everything is animated from that specific object. So if you're clicking on anything else and trying to animate it, it's not going to work because the mandible is parented to this specific object. And to demonstrate what I mean, I'm going to open up the timeline. And in the timeline, we get to save certain locations. So what I'm going to do is I'm going to do the X value, and you can see how this jaw swivels along. And so we're only working with these constraints. And if you get confused, the tooltips are larger now. They appear for 200 seconds until you click the next button. And this is another fail safe. You just read the instructions. The tooltips will guide you through the whole thing. All right, so for example, now if we do, say we want to open it at 2 degrees on a normal articulator, that will equate to ×2. So that is 4 millimeters. I've made this a little bit larger so that we can actually see what's going on. And that's 2, 4, 6, 8. So that's how that works. And then we're going to apply these keyframes. And that sets little orange dots over here. And then we've applied this like that. So that moves like this. Then we're going to set the protrusive, and we are then prompted with the tooltips to move the jaw forward. And of course, we can then close it as well a little bit. Now, these are teeth from a tooth library. So I wish I had the actual patient's teeth here, but I don't. And then we can apply the keyframe, and then this will move forward like this. And then we do all four. So set the excursive movements, and we're going to pull the jaw this way, and we're going to open it up a little bit. And then we're also going to put the Bennett side shift in here, which is between 1 and 2 millimeters. So I'm going to put a -1. You can see when I drag this out, that's what happens in this specific movement. So let's put -1, and then we're going to apply this. And then the last one, the excursive left, we're going to do exactly Bennett side shift. I'm going to put 1, and we're going to move this lower that way a little bit, and we're going to move this open. So this is just arbitrary to show you guys how this works, and apply. Now we are finished. The jaw is animated. And in the navigation, we can then move it around. So we can play it. So here we go. We're playing it, opening it up. Notice that how it's actually moving. Okay, like that. So it's opening up, and then in the protrusive, it's sliding down that eminence there, if you look at it. Okay, and also on this side like that. So it's moving. And on the excursive right, here, this is set. You can see how the Bennett side shift is moving to the left-hand side by 1 millimeter, and it completes the distance at the last keyframe. So at the number 0, it hasn't shifted, and then at number 5, it's reached its maximum of 1. Let's do the other side just to demonstrate, like that. And on this side, it moves down the eminence like that. Okay. So the whole purpose for having an articulator is that we can cut out things, whether
So
it's a
do
splint.
occlusal adjustments and things.
Yeah, yeah.
Mm.
Okay, so that sort of completes the skull. Okay.
Excellent. Are there any
Are there any
questions?
questions?
Yeah,
Okay.
at this point. Michael, would your Wi-Fi or whatever you're on support a camera, your camera or not?
Is my camera not on?
Or at least
Okay,
I can see it.
start.
Yeah, that's better.
Okay. Gosh, the power of mobile internet, isn't it? Just a hotspot.
Yeah.
Jeez.
Why did your
Okay.
internet cut out? Maybe that's another story.
It's the first time my Wi-Fi didn't cut out. It's my actual, the link, it's my internet that's cut out. My
Mm,
Wi-Fi is working.
mm. Oh, well, you're
Anyway,
doing
yep.
really well. So why don't we just unmute um, everybody so you can just ask some questions if you have.
We could just for fun cut the teeth to see how that works.
Yeah, okay. So you mean making a dynamic cut, like using all of the animation?
Yeah, we can try it out.
Oh, well, give it a go.
All right, so when we do Boolean cuts, you can't have like, I think there's 6 or 8 teeth on the top. Even though they're joined, they're not joined. They're not one mesh. So the first thing we're going to have to do in the cutting tools, we have to make them into one mesh. So I'm going to take these and I'm going to voxel remesh them into one, and we're going to apply it. And what that does, it actually fuses the teeth together. So if you look carefully, they've been joined into one unit, whereas opposed before they were in separate units. So I'm going to do the same thing for the lower, voxel remesh it, and we're going
We
to
lose the quadriflow
apply.
remesh button now.
The quadriflow remesh, I found that sometimes gives problems with users. It takes so long to implement sometimes that I think we should rather stick to the voxel remeshing. Yeah, and I think it is reliable, if you know what I mean.
But what I like with the quadriflow remesh is that there is a progress bar while you are doing it, so you can know where you are. And I
How
will,
far it is.
yeah. Is it,
So
a question I ask myself, is it easy to do some progress bar for function in Blender, or it's hard?
well, look, the progress bar with the other remeshing, look, I can add it. It's not a, it's if you like it and other people like it, we can still leave it in. So I mean, we're at the stage where we can just leave it still. Wolfgang, what is your opinion there?
Well, it's not
Okay.
affecting the tutorial, so I'm quite happy either way.
Yeah, okay.
Don't make me
We know.
redo any videos, all right?
And as I seen for the moment, I think that we have to do some new video because the import condyle has changed a little bit, and the Facebow we have to change it. But I see that the cutting tools, nothing changed. So if there is no quadriflow remesh, I'm okay with it. But as far as I'm concerned, I was using it when I do the new TIS library because I want my library to be fail safe for the Boolean operation. But if you say that
Okay.
people don't like it, but perhaps just keep the button.
Mm.
But that's my opinion. Perhaps other user can tell.
Wolfgang, am I dropping out again, or
Just
am I still
intermittently.
here?
Intermittently. You're still all right.
We could just have a pause and I can try and reconnect, or shall I
Oh,
just go
no,
on?
you're fine. You're fine. Just carry on. Okay. Just do your
Okay,
cut.
so in the cutting tools, we're going to keep this as the object making the cut, because I'm going to cut the lower teeth. So object making the cut, and we're going to, don't forget to apply this offset. So we're going to apply this, And then the other one is going to be the object making the object being cut. So let's click on that. And then we're going to cut this all out, cut all the movements.
You know, Michael, this type of operation, it takes a lot of time to make the calcul. Perhaps we could have just some nice tooltips saying that, okay, first cut is done, second cut is on the way, you know, because you can, during the scripting, put this little information in the tooltips. You have a very fast computer there, but when we have a computer a little bit more
Slower,
less
yeah.
powerful, it can take like 1 minute or so to do all the cutting movement.
Yeah, you know, with Blender 2.91, the Boolean cut works absolutely amazing, but it takes a little bit longer, but not too long. Maybe they've made a few changes which are welcome, but the cutting will even cut if it's not animated, which is just perfect. Usually if the jaw is not animated, you can forget it. Everything is in bits and pieces, but not with 2.91. And this version already, this articulator, I made it work in 2.91, but the other versions don't work yet. So I wouldn't recommend, well, we can't. Don't use 2.91 until all of the other ones are 2.91, but this one is 2.91 ready, which is good.
Mm.
All right, so
you choose the old-fashioned Boolean cut, not the new implementation for this module.
For this, I've got a code in it that for 2.83 and for all the other modules, it uses the old code.
Okay.
But when you switch to 2.91, it will use a new code, but it does take a little bit longer, but not that much longer, but it's more precise and will never get failed Boolean cuts, which is fantastic.
You use the new algorithm in the 291.
Yeah.
Okay.
Yeah.
Yes.
Okay.
But
Yes,
but
yes.
the other modules haven't caught up yet, so we've got to still make them compatible.
We don't have to recommend this first point. Okay.
Mm.
Yeah. All right. So let us quickly see what is happening in a cross section over here. So Alt B, and we're just going to just view and see what's happened here. So when I move, I've got the wrong animation. Let's just do view right. Here we go. So here we can see how it's actually trimmed it out. And if I zoom even closer, you'll see that it's been offset by 0.1. Okay, so if I
So
move
this is
it,
great for to avoid high crowns and things like that. So you can set it.
yeah,
If you're setting the offset more, then you guaranteed whether you're zirconia, you're not going to end up with high bites.
exactly. But also the other thing is that it's a fail-safe mechanism. If the Boolean cut doesn't work, go back a few steps and then set it at not 0.1 to 0.9 or 0.11 or 12. And chances is it's the Boolean cutting will work. All right, so I think that completes the skull. Let's say good night to this guy. And we'll open up the next Blender file. Okay, if there's any questions, would be good to ask now, I think.
You can type in the chat window as well, and I'll just try and relay your message to Michael.
All right, let's have a look at the Facebow.
I only have one question after I leave you alone. When you were doing animation, you have five keyframes. And when you do cutting all the movement, you have like 13 cuts. But if we do more keyframe for an animation, do your algorithm cut all the keyframe we do, or do you just only do 5 keyframe for a specific motion?
No, it'll cut number one. It'll cut number one only once, and then it'll go into forward. So it'll jump to number two, 3. No, I think there's 3 cuts going forward, and then three cuts lateral, and then 3 on the other side, right? Because we don't really need more than that because it's spaced like 0.5 millimeters apart or something.
Okay.
You know, so I
To
think
avoid making holes into the model.
more than that would be just overkill, I think.
But you
Yeah.
know, it's just because sometimes I used to animate all the motion for, you know, in one timeline to do my animation. I was asking myself if I can cut all this animation, but I think that for the moment it's only specific for each motion and it's only 5 cuts.
Yeah.
Okay.
Yeah. So yeah.
Just
All right. So let us go into the Facebow now, and this has changed a little bit. So here we've got my niece's mouth, Wolfgang's daughter. Thank you to Carmen, she's a supermodel now, superstar.
She's a triathlete, super triathlete.
Yeah. So again, we're going to name these models. So if they are named before, which it is now at the moment, please just click these buttons because there's scripting behind it, which we need. Okay.
So that'll set
So
the algorithms into motion by pressing those buttons, yeah?
yeah, exactly. And I'll show you exactly why. So I'm going to name this upper, and the tooltips are going to promote me now to do a measurement. So some of you don't know how to do it, but you just left button down and move the mouse to measure the width. I mean, it tells you in the tooltips. So what I'm going to do is I'm going to make a measurement on the specific model. So I'm going to choose landmarks which are sort of similar to a photograph. I mean, if we got the photograph, we've got these landmarks, distal of one, distal to the other. We can put it on the cervical,
Incisor.
sorry, the incisor embrasure. We can put it where the pink meets the white over here. If a person has one tooth in the mouth, okay, well, we'll just put it on one tooth, etc., etc. But we need a measurement because we need to scale the photo according to the measurement of the model. So beforehand, we had the measurement of the pupils, but that's not enough because some people have really black eyes, you know, and some people have tattoo ink in their eyes, like blue or something, and you can't actually make a measurement.
Also, it's a little bit awkward taking a ruler, and who's got a ruler in the surgery? Maybe some people do, but then so it is more complicated than taking an object that's already existent in the 3D world and just, I mean, it's a true to life scale this, yeah.
Maybe with a Peria probe, and you can sort of measure and measure.
Yeah. Oh, that's
But yeah.
tricky, Michael.
All right. Okay. So here we go. We've got the measurement, and we're going to then name the lower one. Okay. And then what we're going to do is we are prompted to put in some photographs. All right. So let me find the photographs. You just go to your Windows Explorer, for example, choose the photos that you want, and you just chuck them into your Blender like that. Okay. Then what we have to do is we've got to name these photos. Please don't move these photos around or scale them, or just leave them as they are, because otherwise it mucks around with things. So this one becomes a front photo, and this one becomes a side photo, and then we're going to place the front photo. Now you'll be able to see your measurement that you've taken, and we're going to relate to this measurement to the ruler. This is called the ruler, and we're going to plug this information into our Blender. So this is 28.06. Okay, and we're going to accept this now, and that'll bring up a new type of a little tool that we need to scale the photo. Now what I'm going to do is I'm going to use the S key to scale and the R key to rotate, because what I'm doing two things. One, I'm going to rotate this to the actual card in the mouth, and two, I'm going to get the landmarks where I had them beforehand. So let's just move it like this. And now in the previous version, we had this card with lines in it. We no longer need those, okay? So
just for the front view.
Yeah, we have them in the tutorial because, you know, at the time we didn't have a picture, but, you know, I mean, this is a better way of doing it. So
Michael,
now what this, so
Mm.
yeah,
So can we
yeah,
just go back a step, this card, and just talk about the card quickly? This is a blank ID card, or like a blank credit card without the magnetic strip. So these are readily available from eBay, okay? And our thinking was that if we place a card in the mouth and take the photo the way it is, so that we only see a thin line of the, so that we only see the edge of the line, it's actually essentially, it's almost like we're putting the patient's teeth onto the articulator mounting table. So we're going to relate that card back to the horizontal plane in Blender, which is then also set to the mounting table. So we're kind of matching the photo and the model and the table, they're all going to be in sync with each other. And then because we know that they are in sync with each other, we bring in the condyles, which are then set according to, you know, conventional articulators in the lab, like Cavo or things like that. So yeah, that's the logic behind the actual card. So
yeah,
these photos are just taken with an iPhone. Of course, if we had 3D scanners that can take facial scans, you can do it that way, but it adds to the cost when you can just take a photo, and you can get quite good results this way.
yeah. So if you run out of cards, please don't use your credit card. Your patient may chew it all up or something. Okay, so jokes aside, okay, so what this has done now, it's we're scaling this object, and then what it's going to do, it's going to parent the photo to this object and snap it back into the original position. So that's what it does. So we're going to click correct front photo, and now we've got the Blender grid. Now we've got a choice. We've got two choices. We can look at this Blender grid, and we can, by eye, move this the face accordingly. Now the old menu, we actually we would actually select the photo and use the R and G key and whatever. Not with this one. With this one, we have buttons. So we've got these
So
arrow
Michael,
buttons.
the objective here is to really, firstly, we're trying to find the midline of the patient's teeth, you know, of the face. So the midline
Yes,
is the objective here. And of course, we know the pupils are, with everybody, it's on the horizontal. So in the previous version, we matched it to both the pupils, but now we're using the whole grid, and we've got another mask template that Michael will show now.
yeah. So we can view this photo. The blue line is an actual object. That is already the mounting table. If you look at it, okay. So we've got the photo scaled correctly, and we've got this aligned to the mounting table. So I'm going to view this from the front again, and then what we're going to do is we're going to use these arrows. So we can click left, or we can click right, or whatever. So it's pretty easy to sort of, I mean, the midline is an arbitrary position in space unless you completely measure the entire face and everything, then we'll get the perfect result. But at the moment, we're looking at the patient and we're trying to get the midline correct. And it's not easy because a photo may have been taken a little bit from the side or from the top or the bottom, and then your nose will be out, for example. You know, so it is a bit of a guesswork, but it's more of an educated guess, I guess.
And also photographic skill. So you can make sure the lens is sort of exactly lined up with the patient's face. And of course the card, because we're trying to get a thin edge of the card. So we know the horizontal
Yeah.
plane is in line with the 3D plane.
Yeah, so certain facial features you can see, like the corner of the eye is on that line, the corner of the eye is on that line. You know, certain facial features help. The nose is a little bit You know, I mean, you can't go on the midline of the nose, even over here. So you can move it accordingly, the photo. You can move the midline, you know, with these. Every time you touch this, it's 0.1 millimeters. So it's very, very fine movements. So additionally to that, we can add a mask. Now this mask is taken from, it's a golden ratio mask. A lot of women use it to measure how beautiful they are.
Symmetry.
You know,
It's all about
it's,
symmetry.
you know, it's
Hey,
available
what
on
do
the
you say? I use the mask,
internet.
Michael. Just kidding.
That explains why you've had facial surgery. Just kidding.
Get out of here, Michael. All right. So you
Okay.
got the mask going. What are you doing here? You trying to match the eyes or the pupils or?
Yeah, so I'm looking at the eyes. We can scale the mask if we want to, and I think the average pupil distance is about, I think, between 54 and 64 or something, and males is a little bit bigger or whatever. But here we can address that, so we can scale this up or down, or we can move it up or down as well. We cannot rotate this because this, remember, this is the midline of our scene. So once we've got all of that, we finish with the facial front photo. We're going to move the model. So here the model may be way off somewhere in the Blender workspace. We don't know this, and we're going to then place this model.
But ideally, you use a model designer to get it more or less in the center, don't you, Michael?
Yeah, absolutely.
Mm,
But sometimes it's not exact. You know, if
mm,
you don't have enough teeth, or if you've got a
mm. A
like a sectional
quadrant.
model for
Yeah.
a
Mm,
quadrant, it'll appear in the center. If you've got a quadrant, if this was a quadrant, you'd actually place that, you know, more or less within the range of these little ovals, for example.
mm, mm.
Yeah.
So are
So here,
you trying to get it to the stopper in front? Is it?
yeah. So this little cube is the stopper. We
A
call that the
rectangle.
stopper.
Mm,
Yeah, so we can rotate this as well a little bit, and we can shift the midline towards a stop if we want to.
yeah.
And then we're going to view it from the front end side. Now the front end side, we're going to then move it to the actual facial photograph. So this is where we're going to pick up any slants in a smile. So if the teeth are upwards, like cans, you know, when it cans upwards. So we can use the R to rotate, and you can see how exact and precise the photo and the model actually fit together, which is beforehand we couldn't achieve such results. So
Yeah.
this
So
is,
here you can see the incisal
yeah,
plane is actually it
tilted.
can tilts up to the in the second quadrant.
Exactly. So if you give this patient veneers, for example, you take that into your equation in the design,
Yeah.
and you may build this side a little bit
And the
downwards.
midline is also slightly out, so we can get the veneers, to near to perfect result this way as far as symmetry goes.
Yeah, and of course, this is for our Facebow articulation. But later on, if you do create veneers, for example, then we know where they need to be. Okay. So here, what we can do is we can select the photo, and we can fade this with the alpha value in and out, so we can see so how good and precise. Now, the posterior teeth won't be 100% exactly because a photo is not in orthographic mode. And in Blender, we're using precise orthographic modes. Okay, excellent. So with that being done, we're going to place it on the side. Okay, so place side photo. And this is a little bit different because we are going to be using measurements of the card. Now the default length is set to 15 millimeters, but you may be using a different contraption in the mouth. I don't know what it's called. Some orthodontists use it, and it actually extends on the side of the face with measurements if you don't use the card. So then you would plug in your measurement over there. So the card, we know it's got 5 markings. So we're going to leave this at 50 millimeters and we're going to accept the length. And then exactly like the procedure before, we're going to grab this and we're going to scale this across the 5 markings. So 1, 2, 3, 4, 5. Scale, and we're going to rotate this as well. So there, and scale it. So try and be as accurate as you can. Okay, using the G and the R key in Blender. So I think that should do the job. Okay.
Yeah, it's looking
So
good.
we've got it over 5. So 1, 2, 3, 4, 5, 50 millimeters. Okay. And then what we're going to do is we're going to click on correct side photo, and that has now automatically scaled the photo and has put it according to our occlusal plane and our occlusal table. We're going to shift the front central incisors to the stopper, and then we can move the model to the side. We can see that, okay, we've got a winner over here.
Yeah, so it's superimposed. All of those 3
Yeah,
things are in sync with each other. The mounting plate,
yeah,
the photo, and the upper model.
yeah. Everything is in sync now.
Yeah.
And if we would now place the condyles, which we're then going to do, we know that this is where the TMJ joint is, more or less.
Yeah, so we can make
So,
a marking on the patient's face there as well. Sort of.
so did you make this marking? I'm not sure. I presumed you took them, you made,
I
but
can't
if
remember.
it's not, then you know that we did take that as a marking, but I can't remember. I may have marked it, but you can actually make a cross in the patient's face or make a little mark or something, and that'll help you as well. Even when you're placing the front, the front, when we're doing the front photo, you can make a little mark on the lip or something. That'll help you a lot as well. I mean, we do that a lot. Even when we make dentures, we make a mark in the model to see where the midline is, and that'll help
On the
you as
wax
well.
spike block, yeah.
So all this additional data is very helpful. Okay, so we're going to hide. We can hide the photos if we want to. We can hide the mounting table if we want to. Let's just keep the photos. We need those photos with the condyle. So I just need to shift this way. All right, so it prompts us to go. It says import condyles. So let's click on the import condyles button, and here we can see they've been brought in at 110 millimeters apart, and we can shift these outwards a little bit. Now remember that photos are not exact. So if you take a measurement from here to there, it may not be 100% because the photography is like in perspective mode. So, you know, this is again a little bit of an arbitrary a thing as well. All right, okay. So we're going to view the photo from the side, and again, we're going to do the same thing. We can move this up, we can move it there. So I'm going to move it this way, and I'm going to move it down where the marking is. So something like that and like that, and we're going to leave it there. We're going to then click accept, which is going to bring in my little guide planes. And we are prompted then to use this side here, the right inclination. And again, we can move this up and down, and we can move this from side to side if we want to. We're going to use the default values, copy that, go to the other side, and then copy that as well, copy. All right. And then after that, we're going to go to the constraints and set our articulation. So here we're going to set open,
So
brings in a little arrow, yeah.
Can you
Brings in
hide
that
the
little arrow.
photos, Michael? Or
Yeah, I just wanted to keep them in to show how it works, how
okay,
it looks like in the actual photograph.
yeah,
So we're going to open up the jaw, So here we're going to open it up. Just say we're opening it up by, say, 3 millimeters, which would be 6 millimeters on an articulator. And we're going to then apply this keyframe.
Oh, you mean degrees, is it? 3 degrees.
Degrees.
Okay.
Yeah. Yeah, 3 would be 6 millimeters on the articulator.
Okay. Mm-hmm.
Okay. So from here, we're going to then do the protrusive. It's going to bring up a little arrow here. Move the jaw forward like that. And we can then open it up a little bit like that. Apply. Set the right side. And shift. We'll just put the Bennett side shift of -1. And we're going to move this jaw. Okay, so here we could hide the photos so we can actually see what's going on. So just go to hide photos. And we're going to just move this way. We're going to open it up that way. Now, the interesting thing is here we can see that we actually got it in the wear facets. And I found that fascinating the other day, and I called Wolfgang up and said, you know what, Wolfgang, if you don't put the Bennett side shift in, we don't get the wear facets. And so this is quite amazing, because if it's a 0, you can see there's no way I'm going to get these. Even if I move this jaw, you can see how it skips past the actual wear facets of the mouth. So this is actually quite exciting. I thought this was exciting. So I've put that at -1 so we can get that exactly correct like this. Apply a keyframe. Other side, do the same thing on this one, number 1, and then move this across like that and open it up a little bit. And we can see there on this side, we've got exactly the same thing happening. Let's just open it up a bit. There we go. That's quite fascinating, I thought. All right, so apply keyframe, and now we've got all of the animations. So view protrusive and play it. Okay, and we can view the photos as well, so we can see from the front side. There, left, and then right. Okay, so I'm just going to grab a drink. If there's any questions related to this, that would be quite good to answer now. Are you, is anybody there? Am I speaking to the universe?
I thought everybody's muted, I think.
Why do you shut people up? This is freedom of speech, Wolfgang.
I know, Michael. It's because you
You
phoned me
can't
2 o'clock in the morning telling me about Bennett's movement.
That's an over-exaggeration. Yeah.
No, Michael gets excited.
I see there are new edit buttons on the articulator constraints. Can you show what the use?
It's straightforward. It's front, it's right, and it's left.
No,
everything.
Articulator constraints. You know there is
these buttons here. Yes. Okay. We've actually had these for quite a while. So just say, for example, you want to edit something, and especially if you're using the automatic one. Let's use the automatic one. I'm going to delete all the animation, and I'm going to delete all the condiles. Nothing is left. Okay. So if we look at the outliner window, so we've only got the photos and we've got the mounting table and whatever. So what we'll do is we'll bring in an automatic one. So I just have to close this because setup.
Yeah.
All right. So if I say name upper and then name lower, we'll skip this now because we've done this thing, and we're going to auto set up condiles. So this brings in our entire
Articulation.
animation. Everything is animated. So if you've got upper and lower models, bring them in. All you need to do is name them and click auto set up condiles. Your entire animation is already there. But you need to edit this animation. And it's very easy to do because in the constraints, you just click on edit. This will select this specific one, and then you just reset it and click on apply animation. Then you want to edit the protrusive. Just take it, edit it, and then apply keyframe. So this is just basically, it selects the object, and then you can then just edit. You can edit your animation, which is it makes things a little bit simpler. The other thing is, if you want to reset an animation, you can delete them here, or you can simply click on this one, and that will reset it automatically to 0. You can click here, it will set it to 0. Okay, so whenever you click, the other thing with this update is that in the past, I've been going on TeamViewer sometimes, and some users click this over and over and over and over again, and I go in and we've got all of these arrows everywhere. And now this has been solved because, as you see, I can click as many times as you like. It ain't going to change, it stays put. So this is a fantastic fail safe. The other fail safe that I've included is that if you bring in the mounting table, again, some of our friends, users, click the mounting table over and over and over again, and it's just like, it's inundated with mounting tables. So that's changed. That's so. All right.
Excellent.
So yeah. Okay. Perfect.
And
So yeah.
the shortcut Control plus X. When you are in another module, you can bring back the navigation. And
Yes, Control X.
What I don't like with this is that when you click back on the viewport after you lose it, it's not possible to have it stuck, in a pop-up.
Yeah, you know what, I need to, we need to look into this, and I've asked Alexander if we can look into that as well, because, that would be a helpful thing, that it just stays put.
And you've got a little cross that you can just click it or something to.
Yes.
Yeah, that's right. Unless we use an easier shortcut, maybe. I don't know. Something that's. Yeah, I'm not
something
sure.
worth thinking
so
about.
much shortcuts in Blender.
Yeah. So look, I'll think about that, because these are like pop-up menus that disappear whenever you click on the workspace, which is a bit annoying, isn't it? Yeah. Okay. Anyway, so that concludes that, and the last section that I want to just delve into is the cutting of a splint. Okay. So we're going to open. Are we out of time, Wolfgang? Are we okay?
We're just on 1 hour now, so make it snappy, all right?
Why? Do you want to go to bed early?
It's 10 o'clock p.m.
All right. Okay. So here we've got an animation of a splint. Now I've seen quite a few people that design splints, and there's this preconceived thing about splints that they should only go 1/3 of the tooth length. And our question is, I mean, we've made hundreds or thousands of splints in a lab, and splints need undercut. And there is a Michigan splint which you can do. I've had so many remakes sent to me. Oh, this thing pops out of the mouth. Okay, we put wire ball clasps in there to keep them in the mouth. Now, we don't have wire ball clasps in the digital world. So we do rely on undercuts, please. So if there are questions, my splint comes out of the mouth, that's because simply it's poorly designed. We need to engage undercuts in these splints. And if I see, you know, let me just grab a pen here. I see a lot of them.
This is on some groups, on some social media groups. We see this all the time.
I see this. Okay. And, you know, my question, how is that going to stay in the mouth? It's just, you know, I do shake my head. But anyway, so that's that's a different subject altogether. So let me just take this away and just show the splint here again. So here we've got a fitting surface, which is the blocked out model. And if I look at the blocked out model carefully, we can actually detect where it has been blocked out. So we can see over here, for example, the servo is here, and this is a blocked out here. So the undercut, if you struggle with having a splint in position, you would need to bring that above that line. So if okay, you can't really see it so well here, but when you're actually designing it, you'll be able to see this quite clearly. All right, so let's just take this away. And okay, so here's one, and we want to cut this out. So we're going to go.
You still there, Michael?
Yeah, but you do a nice pose.
I think Michael's frozen.
Yes. You should not.
He's thinking.
He speaks too much about Twitter. No, he's
I think he's been banned from Zoom.
I have a question. Do you do the blockout before making into Articulator, or you can do blockout even if the model?
I'm back. I'm back.
Yeah. Yeah, you can either way. You can put it on the articulator first and then make your block out. That's probably what I would do. Hey, Michael? First articulate and then block out.
Sorry, first articulator. Yes, always, because you know, in the lab, that's what we would do. We'd articulate a model and then we'd block it out
with some wax. Yeah. Same as lab procedure.
All right, so I think maybe my credit has run out of my phone. my monthly credit is gone, Wolfgang.
Shake my head.
But I'm actually back on my home Wi-Fi. So luckily for that, it's working again.
Okay.
All right, so can you see my screen again?
Yeah. So you were doing the cut next.
Okay, so you know, the reason why I've got this transparent, and I'm trying to get all of them in this like a translucent gray. It used to be a blue. So all of the cutting tools from now on are going to be a translucent gray to color coordinate things a little bit. But the reason why this is in transparent mode is that we can actually see through this. So say, for example, this was a mouth guard, and we just like to, you know, boxer just clench in one specific location. We can then see. And by the way, if you think, oh, where's my fitting surface? That's because we leave the cutting of the fitting surface right to the end because we don't want to damage the fitting surface at all.
Yeah.
So this, okay.
Also, the models are disappeared in this process, so don't be alarmed. It's just part of the procedure.
Yeah, so we can focus on what we're doing. So if we just apply a single cut, just apply a single cut, it should cut out one specific cut. Am I still here, Wolfgang?
Yeah. All the
Okay. It's taking, oh, you know what? I've made a mistake. I'm going to go back. I didn't apply the offset. You see the offset? So if you don't apply the offset, it'll still cut, but it's going to make like a wedge. You'll be left with 1,000 objects with wedged out, which is you can still save it. You just go in edit mode, select a vertex in the model design, and you click on clean, and it'll fix it. So don't be alarmed if you don't set it, but please try not to forget offsetting this specific model. Okay, so apply cut. All right, so here we've got a one-off cut, and we can see through this model. And, you know, again, for a mouth guard, you know, those of you that have the correct printers with the mouth guard material, I wish we had one, Wolfgang, to make a few. Maybe some of our users have. We can test it or something. Although we have once before, haven't we? It was an FDM printer, I think.
Yeah, FDM with a thermoplastic.
Yeah, okay. You can cut the, if sorry, if you wanted to just cut, if you would say, for example, have a splint with only an anterior bite rim, and you just wanted to make a protrusive plane, you would then trim, you would only trim the protrusive over here. But all right, so let's just try that. Trim protrusive. And that's moved the jaw animation forward like that. So there's no other cuts. So if you can imagine for a second, you've only had a front section, like a rim around the front section.
Is that like an NTI kind of splint?
Yeah, I don't know what they call them, but you know, so there's a lot of flexibility on what we are trying to create. So let's just go back, and we're going to apply all the cuts.
So this is the 13 cuts that you're making.
Yeah. So if you're using this for a lower jaw, for example, make sure that your actual splint layer is animated to the lower jaw. Otherwise, it's not going to cut properly. All right. So let's just examine this beautiful trimming here. And of course, you don't want to print it like that, because you're going to have to polish it with a pumice and get your hands dirty, and that's not our objective anymore in the digital world. We don't want to get our hands dirty. We've had enough of this, Wolfgang, in the past. Didn't you like polishing dentures?
No comment.
I thought you were good in that.
No comment.
Oh, well,
I'll have a chat tomorrow, Michael.
So in this layer, in the splint module, find yourself any one of these smoothing layers. They all do exactly the same thing. Smooth layer, and then you can just, just smooth it down. We don't want to destroy our beautiful cuts there. So we'll just take quite a sharp one on the outside. And of course, it has been suggested that, well, not suggested, but we know that it will remesh it as well, which will then smooth it a little bit more as well. So once we've got that done, I'm going to set this to 0.1. And all these instructions are in the tutorial anyway, as far as the splint is concerned. And just give it a quick brush over like this, like that. And then exit. And that will remesh. It's going to remesh the structure at 0.4. and then we can then cut the fitting surface. And again, if we look at this carefully, let's just have a look at the way the animation works, the articulator works. And we need to set this to the right-hand side, I think. Okay, let's just use the Control X. Okay, so let's just set it to the left-hand side. No, it's the other side. So Control X, the right side, and then we just move this along. We can see how it has trimmed it out like that. All right, so even in the anterior section, if we look at this like this from the front side, we can see we actually, these angles relate to the condyle eminence, that blue object earlier on where we've set the angle. This would be the exact angle that the condyle, the TMJ joint would actually move downwards. So let's
Which
have a
is
look
your
here.
33 and 15, and the
That would be
1 millimeter Bennett.
that would be the 30. That's the 33 there, like that. Okay. You can see the inside of it hasn't been cut out. I'll just go back to the splint module and just cut out the.
So that's left to the very end. So creating the inner fitting surface, because we don't want to mess with the mesh as such.
Yeah,
if you were to cut the inner fitting surface first and then do all the smoothing, then you're adjusting the structure of the mesh again. So we want to keep it pristine.
Although in the components module, we've got the fail-safe mask add-on, which will then preserve the inside of this mesh. And I would like to, in the near future, include that as well, that you can, after you cut out the inside surface, we can still sculpt on it and we can do whatever we want on it and it won't affect the inside surface. So that's going to be my next mission down the line. All right, so this one is called the object being cut. In the splint module, we know we're working with two objects only, and that's the layer and it's a target model. So this, we need to call this layer, and with the target model is our fitting surface. This is a target model.
So here you've got one model sitting above the other. You've got the original upper there. You can see that, so that there's no confusion.
No, that's because I've surveyed it quite aggressively standing upwards. So the target, yeah.
But you've got upper there as well. Hey, you've got one sitting over the other.
Yeah, if I hide this one, here is our model.
This is what I'm trying to say,
So that's our model. And you can see, if you look at it carefully, we've got a 0.2 millimeter space going in there. So this depends on your printer, and when you're blocking out your models, you know, if you're milling, for example, it's way more precise. It's like 6 microns or something, whereas printers, we're not there yet, you know, and we're not quite there yet. So so here we go. Here's our fitting surface of this specific splint.
Excellent. All right.
All right, I think that concludes it.
All right, we can stop your screen share.
Gone over time, I think.
Yeah, no, awesome. Well done, Michael. Good job. You redeemed yourself.
I won't let you live this one down, but it's all good.
All right. Are there any questions about the virtual Facebow and the articulator?
You've muted everybody again, Wolfgang. You've silenced the whole world.
I'm pushing unmute, but nothing's happening. But never mind. We're really happy that you could join us. And for those of you who know us, we do this on a Wednesday. Every week we try and have a different topic. So even if you want to suggest something, feel free, and then we'll consider. And we're grateful that you could join. I hope you learned something out of it. We'll be putting all of this video on YouTube, so you can check it on another occasion. And yeah, we just want to thank you for your support, and you guys absolutely rock. So it's great.
One question, Wolfgang. When are you finished with these videos so we can actually release it? I mean, I've been waiting for 3 weeks.
3 days. Sorry, no. Friday, I'll have the Facebow out, and it'll be good. Our Friday night, which was when you wake up in the morning, it should be out. Yeah.
Perfect.
Give me 2 days.
Sorry?
Give me just 2 days, and it's really nice in French.
2 days.
2 days. Oh, 2 days in French. There's a little bit of work in French, to be honest. Not much, but you know, maybe we can just communicate and just get a few things, make it a little bit easier then. Because I mean, you've got a full-time job as well. I mean, this is my full-time job, you know, so during the day it's very quiet, so I get to go on the beach and all of that stuff, but at night it becomes like very busy and early in the morning. Australia is a little bit further behind in digital, I think, you know, even New Zealand. So
I think it's catching up though.
It is slowly, you know, slowly. Yeah.
All right, guys, thanks for joining. It was nice seeing everybody again. Steve, Ivan, Baptista, and everybody else here. Roberto, I see, and Dr. Tsai, and a few others. Yeah, we'll sign off, and we'll see you again.
Okay,
Perfect.
thank you very much.
Cheers, guys.
Bye.
See ya. Okay.